Okay, the next problem is problem 5. It says determine any point in the third quadrant where the tangent of the angle equals 6. So we're going to go to the third quadrant. We're going to draw a reference triangle like we usually do. And we need the tangent of alpha to be 6. Tangent is opposite over adjacent, so I'm going to make this 6 and 1 so that my tangent relationship it would work out to be 6. Okay. Now I'm looking for this point right here. They want one valid point. Well, obviously that's -1 up 6 in order to give one valid point. Oh, I'm sorry, actually it says third quadrant, so let me try that one more time. We want our triangle to be down here, and it says the tangent is 6, so the tangent relationship right here would be opposite over adjacent. So I'm really going to have to make both these negative, and then that valid point would be back 1 down 6. This should be a -6 right there. Now for the next part, it wants me to find the sine of this angle. So I'm going to have to use the Pythagorean theorem to find the hypotenuse. That's 1 squared, or -1 squared if you prefer, plus -6 squared equals c squared, which gives you 1 plus 36 square rooted, which is the square root of 37 for the hypotenuse. So that makes sine opposite over hypotenuse, so sine would be -6 over the square root of 37. Alright, next problem is 6. It says the angle alpha in standard position with terminal side passes through the point 80. So let's say this is the point 80 right there. Determine the values of the trig functions. Sine of alpha is, we can compare this to the unit circle because we're talking about the sine relationships are the same for these different angles. So I'm looking at this point on the unit circle right there. The sine of that point is the y-coordinate, which is 0. The cosine of that point is 1 for that point. The tangent is sine over cosine, so it'd be 0 over 1, which is 0. The cotangent's the reciprocal of tangent, so it'd be 1 over 0, which is undefined. Right, I'm looking at this point, this is 1, 0. So cotangent's going to be, instead of sine over cosine, it's cosine over sine, so it's 1 over 0, which is undefined. And then secant is 1 over cosine, so it's 1 over 1, which is just 1. And then cosecant is 1 over sine, so that's 1 over 0. Sine is the y value here, so that's also undefined. Okay, the next problem says determine whether each of the following expressions is positive or negative without a calculator. So we're looking first for the sine of 66. Now 66 is up here. Sine is the y value, so we're talking about this distance here, that value there, which is obviously positive. Okay, the next one is the cosine of 120. 120 is over here somewhere. We know the cosine is the x value, so that's obviously negative. Now we're talking about the sine of 15 over 8 pi. So I'm going to divide 8 into 15. It goes in once with a remainder of 7, so it's 1 7/8 pi. Now 1 7/8 would be around ones, and then almost another one over here somewhere. We're talking about the sine, so that's the y value there, which is negative. And then we want the cosine of 11 pi over 3. I'm sorry, 11 over 13. So 11 over 13 is not quite 1. So we're talking about a little less than 1 pi over here, and the cosine is the x value, so that's negative. Alright, next problem says for the acute angle, it gives us a sine relationship, so I'm going to draw an acute angle in the first quadrant here. The sine relationship is opposite over hypotenuse. If I do the Pythagorean theorem, it's going to give me 4 here, and then I can find the cosine of theta is adjacent over hypotenuse. The tangent is opposite over adjacent. The cotangent's the reciprocal of that. The secant's the reciprocal of cosine, and the cosecant is the reciprocal of sine. So I'm going to do hypotenuse over opposite, 5 over 3. Okay, the next problem is problem 9. It says we want an angle that's between 0 and 90 degrees. So I'm going to draw a reference triangle between 0 and 90 degrees, and I'm going to label what they gave me. They told me in my problem that the cotangent of theta is 3 over 2. So cotangent is the reciprocal of tangent, so instead of doing opposite over adjacent, I'm going to do adjacent over opposite is 3 over 2. And then I can use the Pythagorean theorem to get the hypotenuse. It's 9 plus 4 square rooted, which is the square root of 13 for the Pythagorean theorem. So now that I have these relationships, it's easy for me to find the tangent of theta is opposite over adjacent. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the secant is the reciprocal of cosine, so it'll be square root of 13 over 3. And the cosecant is the reciprocal of sine. Okay, the next problem is problem 10. It once again gives us some information, so I'm going to draw a reference triangle with that information. Mine says the sine is negative, and the tangent's negative, that means the cosine must be positive because tangent is cosine or sine over cosine. So if the sine's negative, the cosine must be positive in order to get a negative. So that means that the cosine's positive, sine's negative. My reference triangle is going to be in the fourth quadrant then, where the x is positive for cosine and the y is negative for sine. Then I can write these relationships. So sine is opposite over hypotenuse. I'm going to make this -6 because I'm going down. And then I can do the Pythagorean theorem for the hypotenuse. So it's 36 plus 25, which is the square root of 41. I'm sorry, 61. And then I can find all these. So the sine is opposite over hypotenuse, so that's -6 over the square root of 61. The cosine is adjacent over hypotenuse, so that's 5 over square root of 61. Secant is the reciprocal of cosine, so just flip the cosine. Cosecant is the reciprocal of sine, so flip the sine. And cotangent is the reciprocal of tangent, so flip the tangent. Okay, the next problem gives us an angle that's between 0 and 90 again. So I'm going to draw that reference triangle between 0 and 90. And then I'm going to label what they gave me, which they told me that for theta, tangent was opposite over adjacent 15 over 8. And I can use the Pythagorean theorem to find the hypotenuse. That gives me 17, so if I want to find the sine now, it's opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the secant is a reciprocal of cosine, which is going to be 17 over 8 then. Okay, the next problem says that we have a line drawn from the origin on the unit circle, and it connects angle T with the point on the unit circle that I don't know where this is, but let's say square root of 5 over 3, -2/3 is right here. I'm sorry, actually that would not be there. Try this again. That'd be down here, where you have square root of 5 over 3, comma, -2/3. This is my angle T then, all the way around there, but I'm going to use this reference triangle right here in order to set this up. Now, if this is a unit circle, then the hypotenuse is obviously 1, x is the square root of 5 over 3, and y is obviously -2/3, so I'll write it like this. And then I can find the cosine of this angle. The cosine is adjacent over hypotenuse, which is square root of 5 over 3 divided by 1, which is the same thing. The sine of t is opposite over hypotenuse, so that's just -2/3. And the tangent is opposite over adjacent, so it'd be -2/3 divided by square root of 5 over 3. So I'm going to multiply by 3 over the square root of 5 instead. Move that to the top. The 3's cancel and I get -2 over the square root of 5. Okay, the next problem gives me the sine is 3 over 5 and it says the cosine's negative. So I would set up my reference triangle in the second quadrant because that's where cosine's negative and sine is positive. Now the sine is opposite over hypotenuse, so I would label that, and then I would do the Pythagorean theorem to find that this is 4. And then I could figure out the first two are pretty easy then. The cosine of u for this angle is adjacent over hypotenuse, and the tangent of u is opposite over adjacent, so I have those two. Okay, the next part then, we want negative u. So keep in mind u went this way, so negative u is going to go exactly the same but back the other way, so it's going to go back all the way to here. So exactly the same triangle if I can draw it the same, but now rotate negative u. So it's going to be here where this is still going to be -4, and whoops, I messed up. That should have been -4, so that cosine was negative here, and then tangent would be negative as well. But this would be 3 still, and this would be 5 still. So now I can do the next ones, which sine of this angle negative u in green would be opposite over hypotenuse, so it'd be, and this is negative as well, it'd be opposite over hypotenuse. Cosine of negative u would be adjacent over hypotenuse, and the tangent of negative u is opposite over adjacent, so that ends up double negatives cancel and I get just 3 over 4. Okay, the next problem then wants me to take my original angle u, which is the blue one, and add pi to it. So let me get rid of this one. I'm going to add pi now to this angle. Now adding pi brings you around 180 degrees, so you're going to be exactly down here. Make a straight line basically with your hypotenuse of your original triangle. And then this would be the 3, this would be the 4. Now this is negative. This would be the 5. Now the sine of that angle u plus pi would give me opposite over hypotenuse, so it would be -3 over 5. The cosine is now adjacent over hypotenuse, so that's positive now, 4/5. The tangent is opposite over adjacent, so that'd be negative 3 over 4. Okay, the next one then wants us to just add 90. So now we're going to add 90 degrees. So if we add 90 degrees, this would be a right angle. And this is a really confusing one, but you're not rotating this whole triangle, you're only rotating this black line right here. So you want to rotate that 90 degrees to here. And what's going to end up happening is this side's now going to be the short side 3 and this side's going to be 4. And they're both going to be negative here. So now I'm using this black triangle right here. That's very confusing, I know, but if you rotate this 90 degrees, this side's going to be 3, this side's going to be 4. Now my triangle is here. So if I want the sine of that, that'd be opposite over hypotenuse. The cosine would be adjacent over hypotenuse, and the tangent would be opposite over adjacent, which ends up being 4/3. Okay, the next problem says angles in the second quadrant. So we're going to draw a reference triangle in the second quadrant, and it gives us the sine. Sine is opposite over hypotenuse, so if I set up the Pythagorean theorem, I end up with 9 minus 4 square rooted, which is the square root of 5 here. And the cosine of this angle then would be adjacent. I want to make sure that's negative, because I'm going back, square root of 5 over 3. And then tangent's opposite over adjacent, so that'd be negative 2 over the square root of 5. And then the angle u here, alright, to find u, it has to be in radians. I know it's a little confusing, but this is pi radians. So if you do inverse sine in your calculator, what it's going to give you is 0.729 for me in radians. Now I want this angle right here actually, so I'm going to have to take pi and subtract that 0.729 value, which gives me 2.412 radians about. So it's a little confusing in radians, but just because we're not comfortable with that, but we do need our answer in radians, and it needs to be this angle here. Alright, the next problem wants to find sine, secant, and cotangent, and they give us the tangent is 7 over 23. It doesn't tell me what quadrant this is in, so it might not matter. Let's see. Let's draw an acute triangle here, acute angle, and tangent is 7 over 24. And then I'm going to do the Pythagorean theorem to get the hypotenuse. I get 25 if I do the Pythagorean theorem. So then if I want to find the sine, it's opposite over hypotenuse, which is 7 over 25. The secant is the reciprocal of cosine, so instead of doing adjacent over hypotenuse, we'll do hypotenuse over adjacent. And the cotangent is the reciprocal of tangent, so I'll do adjacent over opposite, 24 over 7.